All right, so this video is for question number 2 on 2016. This was to act as a quiz, so please make sure you've done this before you watch this video. Do it on your own. This was a calculator-based question. So with that said, let's go ahead and get started. Question number 2 of 2016. It gives us a velocity, and it gives us an initial position of 2 when t equals 4. Part A, it says, at time t equals 4, is the particle speeding up or slowing down? So we need to remember what speeding up and slowing down comes from. Speeding up comes from the idea that if I'm moving in this direction, I need a force that propels me to go faster. So if my velocity is positive and my acceleration is positive, I'm going to speed up. If my velocity is negative and my acceleration is negative, we're going in the same direction here, it's pushing me forward, then I'm speeding up. If my velocity is positive and my acceleration is negative, then I'm slowing down. And if my velocity is negative and my acceleration is positive, then I'm slowing down. In other words, if velocity and acceleration have the same sign, then you're going to be speeding up. And if they have different signs, they're going to be slowing down. So we have to figure out the velocity when t equals 4. And since they gave you the velocity function, all we have to do is plug in 4 to that. This is a calculator problem, so you should be saving that function in the y list and just typing that in and evaluating. So you should have gotten 2.979. And then we need to take the acceleration at t equals 4. Again, because this is a calculator problem, you should not be taking the derivative on your own. You should be just taking the derivative using your calculator and plugging in 4. But the way we express our work is we do want to show that relationship. So the acceleration at t equals 4 is equal to the derivative of the velocity when t equals 4. And then when you type that in your calculator, you get negative 1.164. And we can see that since velocity is positive and acceleration is negative, their signs are different. So therefore, the particle's the particle is slowing down since v of 4 and a of 4 have different signs. All right, so that's part A. Points on this, you're going to get 2 points. 2 points, and it just says 2 points for the conclusion with your justification. Now, 2 points for your conclusion with justification. So if for whatever reason you got the wrong values for velocity and acceleration, but then you explain this and the justification is correct based on your answer, then you would still get 1 point. So for example, if you got acceleration is positive and velocity is positive, then your answer should read the particle is speeding up since v of 4 and a of 4 have the same signs. So as long as your justification matches your answer, then you're going to get 1 point. If it's correct all the way through, then you'll get both points. So that's part A. Let's go ahead and look at part B right here. So for part B, it is saying that find all the times in the interval 0 to 3 when the particle changes direction. Well, the particle changes direction when velocity changes signs. So the first thing we have to do is we have to set velocity equal to 0, and velocity does not exist in all of that, but the velocity always exists in that interval. So we use our calculator, we find our zeros, we get a time of 2.707. Now there may be other times when the velocity is 0, but within the domain 0 to 3, this is the only one. And so we can see based on the graph that the velocity is changing from positive to negative, or negative to positive, I don't remember which one, but we would say the particle changes direction when t equals 2.707 since v of t changes signs. So that is part B. The points for this, you're going to get 1 point for your answer. 1 point for your answer. So basically saying when t equals 2.707, and then 1 point for your justification. So that's part B. Part C is pretty straightforward. Part C just says find the position of the particle when t equals 0. Let's see if I can put this on here. Find the position of the particle when t equals 0. Well, remember, position when t equals 0 is equal to the initial condition, and it gave us that initial condition. The position was 2 when t equals 4. So it's the initial condition plus the integral of velocity. In other words, it's the initial position plus the displacement. The lower bound on this is going to be 4 because that is the time when the position was 2, and then we are looking for the position when t equals 0. It doesn't matter that we're going backwards here, it's still the same equation. Initial condition, initial position, plus the integral from the time of the initial position, which is 4, to the time that I'm looking for of the velocity. And so we just type that into our calculator, we get negative 3.815. Point values on this, you would get, it's actually worth a lot here. You're going to get 1 point for having the correct integral. Okay, so basically if you had the integral from 4 to 0 of v of t dt, that's 1 point. You're going to get 1 point for using your initial condition. In other words, if you knew that you needed to add your initial position here, then you get the 1 point for that, and then 1 point for your answer. So that's part C. Part D is pretty simple. It says find the total distance the particle travels from t equals 0 to t equals 3. So the total distance traveled is just the integral from 0 to 3 of the absolute value of velocity. So you have to type this into your calculator. Remember, your absolute value button is found in the catalog. So you would type in integral and then catalog find ABS, and then it'll open up another parenthesis. Then you type in, if you saved it in your Y list, Y1 parentheses X close parenthesis, and then close all that, and then you hit comma X, comma 0, comma 3. So you should have gotten 5.301 as your final answer there. All right, and then point values here, you're going to get 1 point for having the correct integral. So this guy, making sure that you have the absolute values there, and 1 point for the correct answer. So again, every FRQ is worth 9 points. There's 2, 4, 5, 6, 7, 8, 9. Go ahead and grade this. Be honest when you're grading it, and then go ahead and input your answers for the last 2 problems, question number 4 on 2014 and question number 2 on 2016 into Socrative, so we can see how you're doing. And then I'll see you again next time. Your next video, or the next question that you're going to work on is a you-do problem, so you get to do this on your own. Question number 5 of year 2017, and that is a no calculator problem.